Good morning, scholars. Um, so this is a lesson on algebraic expressions. Um, I'm going to go over the notes in this video and then the I do's. You should be, I think Mr. Odo should feel free to pause the video at any time so you guys can finish taking the notes. They'll also be posted to formative later today. And I expect them to be uploaded. I expect your notes to be uploaded by Monday. So please make sure that you guys get that done for me. But I'm going to jump right into it. Let me share my screen. All right. So again, today our lesson is on algebraic expressions. You put 7m, 10, 30, 20. That's pretty cool. This is U301. All right. So when we're talking about algebraic expressions, and you guys know algebraic is algebra. It involves variables a lot of the time. And algebraic expressions are just like any numbers, including variables that are separated by addition and subtraction signs. So like 7 plus 2x, and we need to know the mathematical terms, all the different parts of this. So first of all, 7 is what we call a constant. Okay, that becomes important, especially next year when you're with Mr. Speciale, he likes to use constant a lot. Obviously, x, our letter, is a variable. Remember that a variable is just any number, is just any letter or symbol that's representing an unknown. A constant is just a normal number. It could be positive, it could be negative, but it's just a number that does not have a variable attached to it. A number is attached to a variable, like this 2. Remember, 2x means 2 times x. This 2 is actually called the coefficient. Coefficient. I like to think of it with the co part because if it means it has to go with it. Coefficient, it's always attached to this. Now, we actually have algebraic expressions are made up of different numbers of terms. In this case, there's actually 2 terms. And that's important that you guys make sure that you realize this is 2 terms and not 3, as some people will mistake it for. When you have 2x, you don't know what x is, but you know 2x is always going to equal some number. That's a single term. If you separate by addition or by subtraction, those are different terms. And this whole thing would be the expression. Now, it's important to be able to identify the number of terms a lot. So if we had something like 3y squared minus y plus 6, this would be 3 terms. Because there's 3 things separated by addition and subtraction signs. 1, 2, 3. It's 3y squared minus y, or negative y, and plus 6. We could also have something like 12x minus 2xy minus 5y plus 12. In this case, it's 1, 2, 3, 4 terms, again separated by addition and subtraction signs. 4 terms, that'll be 12x minus 2xy and negative 2xy, negative 5y and minus 5y, and plus 12. The reason why it's important to be able to identify terms and the number of terms is because we want to be able to simplify algebraic expressions. If any time, like whether you work with fractions, expressions, whatever, if you can simplify it and make it easier for yourself, that's always going to be the best thing you can do. So we do this a lot of times by combining like terms. And that, of course, brings up the question, what are like terms? What do we mean by like terms? Well, I'm sure some of you probably already know, but we're going to talk about that in 1 second. Let's just start by taking down the title, combining like terms, because the subheading of the squiggly line. All right, so when we talk about combining like terms, what I mean by like terms are terms, again, like any definition, we underline it, put a dash, terms that are constants or have the same variable with, that W with the slash is with the same exponent. Now this is really important, that it's the same variable and the same exponent. Notice, up here, we have 3y squared and we have y, but those aren't like terms. They don't have the same exponent. This y squared, has an exponent of 2. This y, regular y, it actually has an exponent of 1, in case you didn't know that. Just like any variable that's by itself, like this y again, just like any variable has a 1 in front of it if you don't see a number, any variable also has a 1 in the exponent's place if you don't see it. Okay. If it's invisible, it means it's 1. So again, they're not like terms because they don't have the same exponent, even if they have the same variable. Down here, none of these are actually like terms. Even though these both have x's, because this one has y and this one doesn't, not like terms. You know, these both have y's, because this has x and this one doesn't, they're not like terms. And notice this one doesn't have x or y, so it definitely can't be like term with these. And again, our goal with all this is to simplify. So let's take the note that we should always simplify algebraic expressions by combining like terms. There are a couple other things we can do to simplify it, such as if we have a number outside parentheses, distributing it inside, such as if it's being divided by something that can be divided or canceled, finishing off division. But really the base idea behind simplifying is combining like terms. You always need to combine like terms. And once we think that we have combined like terms correctly, we can always check this. So there's a way to actually make sure that you didn't make a mistake. And you just check it by substituting a number that you choose in for x. And again, make it easy for yourself. Choose an easy number. Choose a number like 2 or 3. Don't choose 1. 1 will always get you the same thing because 1 and 1 squared are the same thing. So choose something like 2 or 3. But any of those small numbers are great. So again, this last note is check by substituting a number in for x. Now we're gonna see some examples of like terms and some examples of unlike terms. And we're gonna show you a check on both of them. We're gonna start with like terms. Like terms. Let's do another little skinny line. Then go to the end there. All right. So one example of like terms would be something like 3x plus 2x, because they both have x, they both have the same exponent of 1. So because of the same variable, same exponent, they are like terms. 3x plus 2x would be, well, you just add the coefficients and you leave the variable the same. So that would be 5x. All right. We can check this, and we'll check this in a moment. But let's look at another example of like terms first. We could also have variables with a higher exponent, as long as it's the same. W cubed plus 3w cubed. Again, because both are the same variable, w, and the same exponent, 3, we can add them. And now remember what I said up here, and what I said up here, and what I think you guys should know from sixth grade, that any variable, if you see it by itself, should have number one in front of it. So this is really one w cubed plus 3w cubed. And we just add the coefficients. 1 plus 3 is 4. So we get 4w cubed. And the last example we want to show is just constants. And constants are just regular numbers. So let's say -5 plus 12, that would be 7. Again, because they're whole numbers, well, not, it doesn't matter. Whole numbers don't matter, sorry. But because they don't have a variable, they're just constants, they're like terms. You can always combine them. You know you can add numbers. So let's check these. Check. For this one, let's say let x equals 3. For this one, because we have a high exponent, let's just do a little bit a smaller number even, even easier number. Let w equal 2. All right, in this case, we're trying to check whether the left side of the equation is going to equal the right side of the equation when we plug in 3 for x. That means 3 times 3 plus 2 times 3 equals 5 times 3. Well, we're checking that, so it's a big question mark. 3 times 3 is 9. 2 times 3 is 6. Question mark. 5 times 3 is 15. Now 9 plus 6. Oh, 9 plus 6 is 15. And we know 15 equals 15. So check. That one does work. Now let's check for w equals 2. In that case, we would have 2 cubed plus 3 times 2 cubed equals 4 times 2, not 3, times 2 cubed. A little question mark. Well, 2 cubed, well, that means 2 times 2 times 2. So 2 times 2 is 4. And we got multiplied by 2 again. 4 times 2 is 8. 2 cubed is 8. So here I have 8 plus, let's leave the 3 there for a moment. 3 times 8 equals, with a question mark, 4 times 8. Remember, order of operations, PEMDAS. Exponents come before multiplication. That's a mistake I've been noticing a little bit in the sixth grade this year. So multiply something like 3 times 2 here and get 6, and think 6 cubed. But 6 cubed is very different than 3 times 8. Because 6 cubed would be 6 times 6, which is 36, times 6 again, which would be 216. Way different than 3 times 8, 24. Right, so make sure that you are making that mistake. You do the exponent first. Here we have 8 plus 24. Again, we're not sure yet. Does it equal 4 times 8? That's 32. Oh yeah, 8 plus 24 is 32. So 32 should equal 32. Check. Again, the reason why this works, you're thinking like, okay, 1 copy of 2 to the third power plus 3 copies of 2 to the third power. Well, that's just going to equal 4 copies of 2 to the third power. That's the way to think about it. That's why you need to have the same variable with the same power. You can think of it like the being on the same team. If you're thinking like in sports terms, you just have to match them up. However, these are like terms. Let's look at some examples of unlike terms for the last couple of notes. I had to organize myself over here. All right, page, getting going. Again, you can stop and go back, or these notes will be posted. This might be a long video, so it might not make sense to stop. We will see. Last part of the notes is unlike terms. Again, you'll put a little squiggly line under it. All right, so one example of unlike terms would be something like 5x squared plus 2x. The reason why they're unlike terms, well, they have the same variable, but they have different exponents. This is a 2, this is a 1. So different exponents. Let's look at another example. We have something like 6a plus 6b. In this case, They do have the same power, both to the power of 1, but they're different variables. A and B can't combine different variables. Different variables. All right, last sort of combination of unlike terms. That would be something like 3 plus n. You can't add 3 plus n and get something like 3n. Remember, 3n means 3 times n. So if n was 2, 3 plus 2 would be 5, but 3 times 2 would be 6. So make sure that here you're not combining them. You can think of it in terms of a constant versus a variable. And different teams are always going to play against each other. All right, well, let's check both of these. And let's check a common mistake. So I could see someone doing 5x squared plus 2x and thinking that it equals either 7x squared or 7x. Either way, okay, this shouldn't work, but we gotta check this out. Let's substitute. Let's say let x equal 2 here. That means we have 5 times 2 squared plus 2 times 2. And we're going to see, remember, question mark, what equals 7 times 2 squared. Jot this down a little bit farther. All right, order of operations, PEMDAS means parentheses. Well, I see parentheses here, and the reason why people in statistics get confused because, oh yeah, parentheses does mean multiplication. But when we talk about parentheses in terms of PEMDAS, it's either addition or subtraction inside of parentheses, or multiplication division that's inside of parentheses. Inside of these parentheses is just a number, so you don't need to do parentheses. You look at exponents. All right, we have 2 squared, and we have 2 squared, so 2 squared is 2 times 2, which is just 4. 5 times 4 plus, oh look, we have 2 times 2 again. 4 again. I'm going to see what that equals, 7 times 4. Well, 5 times 4 is 20 plus 4. We're going to see what that equals, 7 times 4 is 28. Well, 20 plus 4 is 24. So no, 24 does not equal 28. All right, so again, you can always check if you accidentally get that 5x squared plus 2x equals 7x squared. You can always check. I recommend doing the check every time just to make sure that you are being very careful. With something like 6a plus 6b, I can see someone doing, okay, 6 plus 6 is 12. We just got to put the a and the b together. So 6a plus 6b might equal 12ab. But it doesn't. Remember, you can't add them, different variables. We're going to see this by, let's say, let a equal 1 and b equals 3. I know I said never really to use 1 for a variable. You can if you have a different variable that's not 1. So most of the time, don't use 1, but again, you can if there's another variable that's not 1. In this case, I'm going to say, okay, 6, well, I don't know why I have penalty there, 6 times 1 plus 6 times 3. I'm seeing what it equals, 12 times 1 times 3. Oh god, that's crushed up against there. All right, 6 times 1 is 6. 6 times 3 is 18. I'm going to see what that equals. 12 times 1 is 12. Times 3 is 36. Well, 6 plus 18. Oh, that's 24 again. It is. But does it equal 36? No, it did not. So again, the check showed us why this didn't work. Please make sure you're doing that check. Lastly, in this video, we're just going to go over the IDs pretty quickly. Please make sure as you're doing these IDs, I don't need you copying them down, or if you would like to, I think that would be a smart idea. But I want you to follow along with my thought process. So please make sure you guys are paying close attention. So for ID number 1, it says simplify the expression 3x plus 2y plus 4x. So I want to identify like terms. One of the best ways to do this, especially when you have expressions like these, is to use circles, boxes, triangles, different shapes, so you can identify different groups. So the easiest one, so, oh look, 3x, put a circle. Oh, well that's y, that's different variable, I can't combine them. So let's use a box. And remember that's a plus, I want to make sure I remember that's a plus. Oh, and look, another x, so that's the same as this one. Oh, use a circle, let's use a circle again. All right, so now, I've identified what the like terms are. Second step, after you identify what the like terms are, you have to rearrange them to put them next to each other. So now I'm going to rewrite it as 3x. Let's move that plus 4x to the next here. Now plus 2y goes to the end. Now 3x plus 4x. Well, you add the coefficients. 3 plus 4 is 7. So, and we leave the variable. Remember, don't make it x squared. Some people make it 7x squared. That's not correct. You have to make sure it's 7x plus 2y. And again, you cannot combine x and y. So we're actually done here. That's it. 7x plus 2y. Again, some of the key steps I need you to follow every time. And this is the work I'm expecting to see on your pages. Boxes, circles, and triangles. We'll see down here. I think I have. Oh no, I have 3. Yeah, I should have fixed that. If you have 3 groups, use a triangle for the 3rd group. A lot of times you won't have more than 3, but if you do, you can use something like a star or something else. Anything to just help you indicate that's slightly different group of terms, group of like terms. All right, so let's look at item number 2. In this case, I'm looking. Oh, look, I have the same variable x, 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 x. Oh, but different exponents. Has to be the same variable with the same exponent. So again, here let's circle in box. I'm going to circle 3x. Oh, that's x squared. Box 3x squared. Make sure you include the operation in front of it. So include the plus sign, the plus sign, the plus sign. Include the plus signs up here. Shown here, I'm going to include the plus signs and the minus sign once I get to it. You got to include those operations. We're going to stick with those numbers. Now, again, I get to an x. X is one of the circles. X squared is my box. All right, second step, rearrange it. Let's make it. Also, when you rearrange it, you don't have to do this, but a lot of times we go in descending order of exponents. So this would be a 1, this would be a 2, we put a 2 in front. Either way, put 3x plus 2x plus 3x squared plus 4x squared, that's fine. I'm going to put 3x squared plus 4x squared plus 3x plus 2x. Notice, I know this came to the front. Well, plus just means positive, so it became positive. This 3x moved over here. Well, again, it's positive, so it's a plus. Now, 3x squared plus 4x squared, add the coefficients. 3 plus 4 is 7. 7x squared. 3x plus 2x, and 3 plus 2 is 5. 5x. And I'm done. And you can't combine them with different exponents. Same way with different exponents. All right, last one. Do number 3. Again, start with your circles, boxes. Circle 3x, box plus 3x squared. Circle plus 2x, box plus 4x squared. Circle minus x. Again, let's rearrange it so the x squared is in front. So 3x squared plus 4x squared plus 3x, remember it's positive, so new plus 2x minus x. Now, again, 3x squared plus 4x squared, well, 3 plus 4 is 7, so this is 7x squared. Here, 3x plus 2x is again going to be 5x, but this time I'm subtracting x. Well, remember, in front of any x, if a variable is by itself, any variable, really, don't have to be x, but any variable, if a variable is by itself, it was one copy of that variable, so it's just a 1. Okay, so it's 5x minus 1x. Well, 5 minus 1 is 4. So that means I have 7x squared plus 4x. Again, I can't combine them, so I'm done. All right, so that is all of our notes. That's all of our IDs. I'll be joining you guys shortly. Please make sure you guys are working through the redos and the IP carefully. Let me know if you have any questions. Either now or during specials later today. But otherwise, have a great time working. I don't know about a great time. But so quickly, so you guys don't have much homework. Thank you for sticking with me and thanks for watching the video. See everyone later. All right.